Hello guys, welcome to Electronics. So in today's episode, what you're seeing right in front of you is a half-built project which has already been started with no intention of recording and making a video about it. But still, it ended up in YouTube like that. The reason being is I have made so many videos thinking that okay, it's too silly to put in YouTube, but then after publishing that videos, I have received so many positive comments for such kind of videos. Because for some people who knows about electronics, they may find it silly, but for those who are the beginners, who will find it useful. So it's those kind of people are actually, uh, look for these kind of videos. So that's the reason why even after starting with the thought that I'm not going to make a video about it, I changed my mind right in between and started making a video. So as the title suggests, in this video I'll show you how you can convert your dead old CFL bulbs into an LED bulbs. So straight away let me show you that you're going to require a dead CFL lamp, and being uh, being in the field of electronics when this was a large thing that replaced the incandescent bulb, I literally had a collection of different wattage, different brands of CFL bulbs. This types the spiral kind of one. In my attic, I have a box that is full of CFL bulbs, which some of them are still working, some of them are not working. Some of them the ballast this thing is gone. Some of them the tubes are gone. But different issues basically. But at that time, people used to give me that LED, that CFL for repairing, and I used to keep a lot of them for spares and obviously for reusing and taking for spares and other things. So I ended up having literally hundreds of CFL bulbs. So I need a way to properly dispose them all, because right now no one uses them and no one brings me to repair them either. So the only good thing that you can do from that is to salvage the board, like the driver board from the CFL tube. So it's actually good for parts. You can get a lot of parts from this. That's the only use right now I have. So I decided to somehow make a use for it, and that's how I ended up taking the base of the CFL. You don't need the tube portion, you can just break it off and just take the base for this build. Now, being an LED bulb, you may be wondering where is the LED. Now this one, as the name suggests, as the title suggests, this one, in this video I'll show you how you can make an LED night light. And I have already made a night light, and this is the one I have been using for a long time. This is a simple version. It's just RGB LEDs and USB connected at the other end. So at night this gives you plenty of light. In fact, I'll show you I'll just give a demonstration, and you can see it's a nice splash of color RGB, and the being connected in parallel, the voltage across every LED is around 2 volts, because the lowest voltage LED, the lowest 4 volts voltage drop LED has pulled down the voltage across all the LEDs. But in this case it's actually a good thing, because a night light does not have to be too bright that it disturbs your sleep. It just have to be there. Okay, anyway, since what I'm going to do, I think you have already got the idea. I'm going to put this one in here, so I'll explain this circuit now. Before that, let me show you how much current it draws. I'll put the USB meter in here, and let's see. It is drawing around 0.07, that's around 70, maybe it's 70 I think, because everything 246 something like that. So it's around 70 milliamps, and the wattage power consumption is, let me bring it close to the screen, and let me focus onto that if it can focus. Okay, the power consumption is just 0.36, that is 36 milliwatts. So it's in a power bank like this one, I'm getting like a month of usage if I'm using it for just, let's say, 2 hours every night. This simple power bank will last you for like a couple of months. So now I have decided to convert this to an LED one, and as I said, I have already started the project because I had no intention of recording it, but still, since I started recording, I'll explain what is happening in here. So this is a very simple transformerless power supply. You can see it over here, it's a transformerless power supply, and this is a 47 nanofarad capacitors, 2 of them connected in series with the bridge rectifier module. This is a full bridge rectifier module over here. So I'll explain the circuit. You can see there are 2 resistors across it. That is a discharge resistor for the capacitors, and that is the reason why I did 2 capacitors instead of 1. So in a normal capacitive power supply, the transformerless power supply, it only has 1 capacitor. But since I don't have for 100 volt rated capacitor right now with me for this project, I took two 250 volt capacitors and connected in series, one in series with the phase and one in series with the neutral. So here goes the input and these discharge resistors across the capacitor as well. And at the output of the full bridge rectifier, you don't need to use this, but this is a W10 full bridge rectifier, is capable of delivering up to 1.5 amps. There is a 6 volt Zener connected at the output side, just in case if any LED goes bad, the Zener will limit the voltage at the output terminal. And input inrush limiting resistor over here. I'm not going to use any capacitor because it's okay for it to have a little bit of flickering, because I'm not going to do any recording or anything at that time. So this is going to be even since that capacitor is not present, it's not necessary to put one over here, but still anyways let it be this if I decide to update it in the future. I have kept a 100 ohm inrush limiting resistor in place, and across that is this is a 47 nanofarad and this is a 470 nanofarad capacitor over here, 1 kV rated, just to just like a noise arrestor, like a flickering arrestor kind of thing, just to keep the spikes down a little bit. When you connect it and when you take it out, this is going to help out a little bit to discharge the spikes. So that is a basic setup, and the case is already this one. The case is for my Philips 14 watt bulb, and you can see it's a quite comfort fit over inside the case, and it's quite flush with the top. So even if you have the LEDs on top, it's not going to make a direct connection with that. So I'm going to use hot glue for attaching the LEDs in here, and I have some soldering to do, and I'll come back after that and I will show you how everything is connected. Okay guys, so the build is now complete and you can see how portable it is right now. So before anybody asks and before powering it up, let me show you the circuit diagram for this thing. So this right here is a circuit diagram. Let me focus onto that, and I think I can zoom as well. So this right here is a circuit diagram, and I have made some changes in the actual unit which I shall open and show you guys. So the line goes through a 100 ohm resistor, which is now removed because of space constraints inside here. I'll open the circuit board and show you guys. And on the neutral side I have kept an optional fuse, which is also not present, but it's quite optional. If you want, you can add that. And then it goes through the two 47 nanofarad capacitors connected on phase and neutral lines, as you can see. And across that are the discharge resistor for those capacitors, and 47 ohms connected in series, which brings it down to somewhere in the 25 nanofarad region, which brings up the impedance. So the resistance of the whole circuit is so high that it's not going to even register in most of the equipment if connected on the main supply line, because the current flow through it is very low. And the reason why I emitted this 100 ohm resistor is because there is no capacitor connected at the output side. That capacitor, when the lamp was not being used for a long time, the capacitor will not have enough charge in that, so initially it acts like a short circuit. So it is to limit that one, we are adding a inrush limiting resistor, but in this case it is not present in the circuit, so you can remove this one if you want. If you're adding a capacitor, it's always necessary to put inrush limiting resistor in the input side. So it purely depends on your application. For my application, it is not necessary as well. And in here is a 6 volt Zener, which is just there in case if something goes wrong in the LED, the voltage should not rise above the 6 volts. And the same applies for the Zener itself, because there is enough resistance created by the network itself. You don't need a separate resistor for this one. It's not going to even turn on under normal operation, because the voltage across here is going to be just 2 volts, which is the voltage drop of the lowest 4 drop LED in the circuit. So these are the 4 LEDs individually having the 100 ohm resistor in series, which is also optional. I'll try with and without that, and I'll make a separate video for that. So this right here is the circuit diagram. Now let's bring back to the whole thing. Let's keep this thing aside, and here is the item that I built. Now let me open it and show you how compact it is. So here is the circuit that is inside, and as you can see, if I had that 100 ohm resistor, you might have seen that in the previous clip that there is a 100 ohm resistor down there, but now it has been removed because there is not enough space. If that resistor was in place, this top portion was touching the LED side, so I just removed it because of purely this reason which I have explained already. Now the LEDs are just simply hot glued with the resistors connected like that. This is the common point, the negative and the positive connect the opposite side. The next thing I will do is I will hot glue the whole inside of this thing and on the connections of this thing itself, and that way it is much more safe to handle. Now enough of talking, let's power it up and see what will happen. So give me a moment. Okay guys, now the build is entirely finished. I have closed it and I have used enough for glue inside so that there is no short circuit or anything. Now let me light it up using an isolated power supply first. So why I'm using an isolated power supply is because I have to test this power supply as well. So you can see it's lighting up and it is bright enough for a night light. It's the camera is doing it justice by amplifying the intensity, but it is not that intense in the actual light. So now since it is working in the isolated power supply, which I will make a separate video, I have a meter ready over here. So the meter is ready and let's turn it on and see whether the meter is able to detect this light as well. I don't think that is going to register because the power consumption is going to be in milliamps range, which is not sensitive enough for this one. So that's why I said in most of the cases the energy meter will not even register this one being connected. So this is now connected. You can see I'll keep the circuit on the right side itself. It's let's just quickly move through it. So the power factor is even 0.5, so it has registered something, and let's see the watts. It's a 50 Hertz frequency and nothing. There is no nothing there. This is different. So as I said, this is because it's using a capacitor dropper. This is not going to be even registered in most of the energy meters, the circuit. Now as an extra bonus, I will check this light tonight to see if the light is enough or if it's too bright or something. If it is too bright, and I will make a separate diffuser for it using this plastic sheet which is lying around. So if a diffuser is required, I will make a separate video for that. So I hope this video will help you to make your own night light in a better way, and this will also help you to get rid of all CFL lights which is lying around your home. Now the LEDs are purely optional. The color of the LEDs are purely optional. It's subjective to your desire. You can put it as whatever color you want, and here I chose 4 LEDs because it has only 4 holes in here. If you are putting smaller LEDs, you can put more LEDs in groups for each hole. That also can be done. And yeah, so the color actually can be changed. It's a quite hackable device in its own right. So that's it. That's the homemade, very inefficient, but it's quite good in its own rights. The way you can dispose of old CFL lamps, convert it to LEDs and make some good cool night lights for your room. If you want to see the power consumption and other calculations, just comment that down below, because the video is already been so long. I don't think I can include that in here. If you want to see that calculation and other things, I'll make a separate video. Just comment in the comment section. Okay, thanks for watching. That's it for today's video. Thank you for watching, guys. See you in another video.